Question 5. So we need to compare the two statements from these women, these girls. This one says that the density is going to be the same whatever the size of the stone, okay, as long as the type of the rock is the same. So let's just think about that. The size of the stone is all to do with the volume of the stone, and then the other thing that we need to know is we need to link it into this formula here. This girl says that bigger stones will have a higher density because they are heavier. So let's just think about her statement first. If the stone's bigger, then it's going to have a big volume, and if it's heavier, then it's going to have a big mass. So what you can see is that we've got big and big, and they're just going to cancel out, and the density is going to stay the same. So this girl's wrong. This girl's right, because whatever the if this increases or decreases, then if the volume increases, okay, then the mass is also going to increase as well, okay, which means that the density is going to remain the same. So now let's just have a look at the question. Who's correct? Well, obviously it's Kalpana, although you don't get a mark for that, so we haven't actually earned ourselves any marks yet. If we'd have put Christine, then unfortunately we'd have got 0 for this question automatically, but just putting Kalpana isn't enough, so now we need to do our explanation. So just for writing down the equation, that would get you the first mark. To get the second mark, we need to get this idea that if you increase the mass, if you increase the volume, then the mass will also increase by a proportional amount, and therefore the density will stay the same. So that should be enough to get us 2 marks. So which measuring cylinder would give the most precise measurement? If we look at this measuring cylinder, okay, it's only marked off to the nearest 5 centimeters cubed. If we look at this measure, so let's put that one there, 5 centimeters cubed. If you look at this measuring cylinder, okay, then with this one you can measure to the nearest 1 centimeters cubed. Okay, so that's better, that's more precise. With this one you can see that you can actually measure, that's split into 5, so you can actually measure to the nearest 0.2 centimeters cubed. So the answer is that A is the most precise, okay, and you could say that it's because it's got the smallest scale or because it's got the highest resolution. Next question is about accuracy. Now the difference between precision and accuracy is that precision is how many decimal places or how many significant figures that you can read off the scale to. Accuracy is how close is that value that you read off to the true value. And there's some reasons why readings can be inaccurate. One might be that it's got a 0 error, which means that the scale doesn't start from 0. Another reason might be that the scale is not calibrated, which means that it's not being the markings on the scale are in the wrong place on the plastic. And that's the reason, for example, that chemists always say that, and they're quite right, you should never use a beaker to measure volumes of liquid. You should always use a measuring cylinder, because the scale on a measuring cylinder is calibrated, the scale on a beaker is not calibrated, so it's not accurate. And finally, a third reason could be that the cylinder's not flat on the table, and you can see from my little diagram here, there's the level of the liquid, okay, and it's difficult to tell exactly where it's at because it's not flat on the table. Okay, this is a classic calculation question. This is simple recall. Density is mass divided by volume. You can do it as a simple equation, or you can do it as a word equation. Either is fine for that, and there's 1 mark available for that. The next thing that we've got to do is substitute the values into that. So that's 54 divided by 23. Okay, and that gets us 1 mark out of 3. The next mark is for the answer, which is 2.3, and you know that it's 2.3 because here there's two significant figures given to us, here there's two significant figures, so in our answer must be to two significant figures as well. And then the final thing that we need to do is put in the units, which of course are grams per centimetre cubed. Okay, so that's 1 mark for the formula, 1 mark for the substitution, 1 mark for the answer, 1 mark for the units. How can she use her value to for the value of the density? Whoops. How can Kalpana use her value of density to identify the type of stone? Well, the first idea is that we need to make a comparison. So we're going to take that 2.3 that she got, and then she's going to compare it with a standard value. Now you could find the standard value in a data table, which you might find, data table, or you might find that data table in a book, or you might find that on the internet, and either of those are okay. So 2 marks, one for making a comparison, and then the second one with a standard value from a data table. Why might she still be unsure about the type of stone? The stone rocks, the density of a rock might be quite similar, so you might have one rock that's 2.3, a different type of rock that's 2.4, a different rock that's 2.5, and she might not know exactly which one of those rocks it is. So that's one idea. A second idea is that the rock might be impure, and typically we only have there's only things that are pure substances. We only have those values in data tables. So for example, you can look up the value of pure water, but you can't look up the value of sugary water because we don't know how much sugar is in the water. So it might be impure rock and therefore not in the data table. And the third way that you could get that marking point is by stating that possibly the measurements of M or V were inaccurate.